thank you for joining today's lunch learning session. So today I will be presenting about introduction to electric actuators. All right. So let us start. Let us start my share screen. Okay. All right. So let us start our sharing. So today the topic I'm going to talk about is electric actuators. So I believe in our previous session we already talked about type of actuators. So before we go into electric actuators, so let us do some revisions. All right. So there are few types of actuator, okay, in the market. These are the common ones. So the first one is manual actuators, or we call it manual hand wheel, or the gearbox. So this is the one we're talking about. All right, it's a manual lah. Okay, and then the second one is a pneumatic actuator, where it's operated by using instrument air or process gas. Okay, the third one, which the one we're talking about, is electric motorized actuator. Okay, and then the last one is hydraulic actuator. This is the one. Okay, this one I will be sharing a little bit about this actuator as well in today's session. All right, so okay, so let's move to electric actuator. Okay, so there are two types of actuators, electric actuators. So the first one is on the left you see is we call rotary. Okay, rotary means when rotary means the actuation of the direction is from 90 degrees. So it's mainly used for rotary valve, for example, like ball valve, butterfly valve. So these valves are all considered rotary. Okay, so this rotary valve, meaning to say, is only rotate 90 degree or or to a certain range of degree defined by the user. Okay, and then the other one we call multi-turn. So multi-turn is also basically rotation, but it's turning, it's going multiple turn. So this kind of actuators is not commonly used for linear valve, for example, like a gate valve. Okay, so or a growth valve. So it basically goes up and down. So the shaft of the what is it called, the stem, the shaft, it will be threaded. Okay, the shaft of the valve will be threaded, and then it will go inside this multi-turn actuator. So when the valve continues to continues to rotate, it will act like a screw, okay, to move the stem upwards or downwards. Okay, so another during the sizing, because this valve normally they have of course they will be based on the valve size and then the torque values. They will have many different kind of the torques. Okay, and then we will also define what we will do the calculation, the sizing, and then we determine what are the sizes. So for example, let's say if we have a very big valve, okay, a big ball valve, for example. So the ball valve we're talking about like 20 inches or 30 inches, where the size is very big. So based on the sizing, okay, based on the sizing is not hard to imagine lah. The size of the actuator is going to be really big. Is that right? And then because it's a ball valve, so naturally it will go to rotary. Okay, the one on the left, this is the rotary. So, but we have another option. Instead of using a large size rotary electric actuators, we can opt for another option, which we can use multi-turn. Okay, multi-turn, how does that work? Do you see this part on the bottom of the multi-turn actuator? So it's basically a gearbox. Okay, so the gearbox will be mounted similar to this one, the manual actuator. It looks similar to manual actuators. Instead of using the hand wheel to turn round and round, we attach this multi-turn actuators, the motorized actuators. So where we can, by doing this, our size will be much smaller in terms of sizes. So of course, by doing this, the in terms of cost pricing is will also reduce. Okay. All right. So we move to the next slide. Okay, so we're talking about applications. So application is called, this electric actuators is commonly used in tank farms, terminals, power plants, and also manufacturing. So manufacturing, we're not only talking about electric actuators, so we're also talking about servo. Okay, these are also considered as electric actuators. And then anywhere that where the instrument A is not available, so the people can also opt for electric actuators. All right. Okay, we move to the next. All right. So what are the main components of the electric actuator? So the first part, of course, we're talking about motor. Okay, it's straightforward. And then the second part we call actuator control. So the actuator control, this is the part. Actuator control basically talking about the settings and then configurations where it receives the signals, and then it also controlling the internal part of the components. Right. And then the third one we call sensors. So what are the sensors available inside? Because we definitely need something. The actuator definitely need to know what they are doing, so they will need many kinds of sensor within this enclosure, this actuator. So the sensors can be thermal sensors, okay, thermal sensors, position sensors, torque sensors, and also like limit switches. Okay, these are the sensors available inside the electric actuator. And then the next one will be gearing. Okay, so this part, if you see this part, this one is gearing. So gearing basically, it means the motor will just run as just like what a motor did lah. It just spins. And then of course the rotational force goes to the gear. Okay, the gear from here, the gearing will convert this energy into the kinetic force, which is to turn the valve, to actuate the valve. All right, and then of course the last part here is manual override. So you see a hand wheel here. So there is always the hand wheel available. So just in case the motor doesn't work anymore, but we still need to actuate the valve. So what will happen? We will need human intervention. We will need someone, the operator, to go up there and to turn the valve manually. Okay, and then okay. So how does it work? The working principle. How's it works? So actually it's very simple. Okay, it's very simple, the working principle. So let's say this is the actuator. Okay, the first part, the signal from the control center. So the signal, meaning to say it can be of course it can be electric signal from the control center, or it can be simply a switch from the operator. Like for example, just like a light switch, you just switch on the light switch. This is the signal for the actuator, and then the power comes from another source. So this power is basically to generate to power up the motor. So the motor will, of course, they will have different kind of ratings. Some of them they have single phase, okay, single phase, and some of them have 3-phase. Some of them can even have a DC motor. All right. So this kind of motor, of course, have to be predefined to suit the motor will be customized based on a client requirement. So before we select the actuator, we need to know what are the type of supply to the motor. All right. So this motor, of course, it goes will turn spins the motor, and then it goes to the gearing. Okay, from the gearing, it will generate the motion to actuate the valve, either in rotary type 90-degree or a multi-turn to go. The motion will be up and down. All right. So it's actually very simple, only just a few components and then straightforward. All right. So what are the safety measures available there? Because we're talking about inside the plant, and then there will be we're talking about electricity there. So of course there will be some kind of safety concern, or will there be any sparks generated, or will it be overheated? Because we're talking about AC, is it safe to operate or not? So these are the normally the questions that will come up. So there are several types of safety measures available. With the first one I'm going to talk about is the torque sensor. So what are the torque sensor does? The torque sensors basically it monitors the torque value. Because for example, if the valve operates for starting to jam, for example, okay, so the torque sensor can actually sense that the torque is actually beyond the limit. So it will, instead of forcing the motor to continue to turn, it might break the component. So once it reaches a certain kind of limit torque, it will stop and then comes up with an error or a warning. At least it will not do further damage to any of the components. Okay, so the first one is the torque sensor. So the second one is a position sensor. Okay, position sensor basically it just tells you what is the current position. So if the position goes beyond the limit, okay, meaning to say it might also then damage the component as well. For example, like for the valve if the valve only opens at 90-degree, but the position actually goes for more than that, so something might happen. It might cause some kind of process upset or even the valve itself. So the position sensor is also very important to monitor the current position, make sure it doesn't go beyond limit. All right. And then the third one is a thermal sensor. So thermal sensor, basically it just monitor the temperature. So just in case the motor gets overheated, so of course when it goes beyond the temperature limit, it will stop the operation. Okay, stop the operation and then comes up with a warning, telling you at least this motor gets overheated or the enclosure gets too hot. So it's not safe to operate. Okay. And then of course the enclosure themselves, the enclosure itself is of course weatherproof or explosion proof, depends on the requirement, depends on the area, depends on the zone. All right. And then of course the last one is we call diagnostic and alarm. So some of the electric actuator range, they have this kind of diagnostics feature where they can perform their own self-check, and then they give the end user early indication of what is going on with the valve, and then is there any future maintenance required. So at least from end user, they will do some early planning to for example to get the spare parts earlier, so at least to avoid this kind of unwanted shutdown. All right. Okay, so this is a very simple only for the electric actuator. So now I'm going to touch a bit on the electro hydraulic actuator. So how does it work? So this is a photo of an electro hydraulic actuator. So basically it's a combination of both. One is the hydraulic, okay, of course, and then also electric. So electric works as a primary because this is we're talking about the hydraulic system, correct? The hydraulic system, we need something to pump in the hydraulic oil into the actuator so that it moves. So how do they pump? They will be using electric motor. Okay, So this electric motor, of course, just similar to very similar to previous electric actuator. So the actuator the controller will receive the signal, and then the power supply will generate electricity to the motor. So the motor will starting to pump in the hydraulic oil into this Scotch and York actuator, right? So that the actuator will move. And then of course, if by doing, some people might ask, why we need to use hydraulic, and then why not straight away we use the electric motorized actuator? So one of the reason, this kind of setup, actually they have spring return option, because you see this one is basically just like very similar to a Scotch York, and then inside this chamber they will have spring, so they will have spring return option available for this kind of setup. Okay, so I think that's all for my presentation. So if let me check on the comment. Do you have any questions? All right. Okay, one of the questions here from Jaja Razin: how to know when to use electric actuator? Okay, other than depends on datasheet. So how to know when to use? Basically, the advantage, I would say, the advantage of using electric actuator is very straightforward. Okay, let me go back to the main component here. Okay, so what's one of the advantage of the motorized actuator is very simple. In terms of maintenance, okay, other than talking about we don't have this pneumatic air available in the area, that is one thing. But if we have using the electric actuator, it's very easy to maintain, because you don't need to worry about is there any leakage or not, because if we use pneumatic, there will be leakage. Okay, you need to maintain. And then if we're talking about hydraulic, you need to change the oil, and then the oil might leak as well from the fitting. But using this is very straightforward. You just need to take care of the motor. There will be no leakage, just to make sure the enclosure is properly sealed, and that's it. All right, so it's quite straightforward, I would say. All right, and let me see. Okay, I think that's all from the comments. All right, so I think that's it from my presentation, and then I hope everyone learns something from the presentation here. So if you have any other questions, feel free to comment inside here, inside this comment. So I will respond as soon as possible. All right. So thank you very much. See you all again soon.